Hi guys, okay, let's go ahead and get started today with lesson 3B. We're still looking at cofunctions and we're going to be looking at some similar figures. Okay, so here we go. What do you need to find in order to solve the triangle? In other words, what does that mean to solve the triangle? In order to solve the triangle, that means that you have to find the measure of all the missing angles, and you have to find the lengths of all the missing sides. So we would need to know the measure of angle A, the measure of angle C, and the length of AB. Now to find the length of AB, we can use our Pythagorean theorem. I'll label that as x, and you would just set this up as your x squared plus 7 squared equals 14 squared. So you would end up with x squared plus 49 equals 196. Subtract 49 from both sides. You get 147. Take the square root of both sides. And then you see if it simplifies. And with your calculator, you find out that it simplifies to 7 root 3. So that we know the length of AB equals 7 root 3 units. Now, we can also use trigonomic ratios to find the measures of angle A and angle C, and we're going to do that in our next lesson. Okay, find sine, cosine, and tangent of the measure of angle A. So if I'm looking at the measure of angle A, I can use my values to find sine of A, cosine of A, and tangent of A. Sine of A is my opposite over my hypotenuse. I can simplify. Cosine is going to be my adjacent over my hypotenuse. And my tangent is going to be my opposite over my adjacent. Let's see if I can get this to go back. So then tangent again was my opposite over my adjacent. Okay, now we have to do sine, cosine, and tangent of angle C. Angle C is the other acute angle. So we're looking, since we did A first, we're going to do this as A. A is theta, and C is going to be by 90 and minus theta. And if you remember from our last lesson, the sine of C is going to be equal to the cosine of A. Sine of C, same as the cosine of C, same as the sine of A. And then our tangents are going to be reciprocals. And how do they compare? Like I just said, that we know that our cofunctions are the same. We know our tangents are flipped, or reciprocals. And as far as the measures go, we know that the angles are complementary. So I know that the measure of angle A plus the measure of angle C equals 90. Okay, let's go through a few practice problems together. I'm going to draw right triangle ABC just as a place to give myself, a place to put my thoughts. Where angle ACB is 90 degrees. That's my vertex, meaning that C is my 90-degree angle. That I can label the other sides A and B. It wouldn't matter, or my other angles, not sides, A and B or AB. Just a place to put my thoughts. Now I know that AC is 10 and CB is 24. And I want to find the length of AB. That is going to be with the Pythagorean theorem. That's going to be my 10 squared plus 24 squared equals, I'm going to label this X. Following the Pythagorean theorem, you will find out that X equals 26. So the length of AB is going to be 26 units. The cosine of A, that's my angle of interest. Cosine is adjacent over hypotenuse, so that's going to be my 10 over 26, which simplifies to 5/13. The cosine of A is equal to the sine of the other acute angle. Write each trig function in terms of its cofunction. So sine of one will have to be cosine of the other acute angle. We know that these angles are complementary, so they add to 90 degrees. Cosine and sine, again, complementary. Cosine and sine, again, complementary. So the sine of x, sine, I'd have to have cosine, and I could say 90 minus x represents the other acute angle. Sine of 6, cosine 66, cosine 45, and we looked at this in the last lesson. This is my isosceles. Right triangle. Very special. Now cosine, the cofunction is sine, co of sine, and again 90 minus x. Okay, multiple choice. These are typical types of questions you see. In right triangle ABC, sine of A is 0.8. Well, the sine of A is equal to the cosine of the other acute angle, so that this would also be the same value. Find two equal trigonometric ratios from the options given. So I know, okay, sine, cosine, tangent. Well, tans would have to be reciprocal, so I've got to do a sine and a cosine, and they have to equal 90 degrees. So sine 30 and cosine 60. So two possible simplifications of sine 31 plus cosine 59. So sine 31, if I put that into the calculator, it's 0.515, and it's equal to the cosine of the other. So I'm looking for things that are equal to 1.03. 2 times sine 31 does equal 1.03. Thinking about it, even without the calculator, these are the same thing. A plus A is 2 times A, so 2 times that value. This second value ends up equaling 27, but 2 times cosine 59, that's going to be 1.03. And again, 2 times the same amount is the same thing as adding the two parts together. This will have a negative 47. But you can also use your calculator to help you figure this out. Now, triangle JKL is similar to triangle QRS. We need to think about this, similar figures. This is very important with your trig ratios. Now, with similar figures, we know our corresponding angles has to be corresponding. Angles are congruent, meaning they equal in measure. So angle J is congruent to angle Q. J and Q are in the same positions with the mapping. K is in the same position as R, so angle K and angle R are congruent. And then L and S, and those are markers by 90-degree angles. The other thing we know about similar figures is that the corresponding sides are proportional. Meaning, guys, they're going to reduce to the same ratio. So that means that when I do sine of k, 9 over 15, that's going to reduce to the same this over this, whatever those values are. So the trig ratios will also reduce to the same values. Very important ones right here. So sine of j, think about opposite is going to equal the sine of r. Nope, that's the other angle. The sine of j, sine of s. Nope. Cosine of k, cosine of q. It would be the sine of q, not cosine. So cosine of k, which would be adjacent, and then the cosine of r, which would be the same. Okay, take a look here. We're looking at another right triangle, and x and y are the complementary angles. Okay, the value of tan of x, so I'm thinking about x, is my opposite over adjacent. So I've got 14 is my opposite, 48 is my adjacent. I'm going to use my Pythagorean theorem to find out that is 50 units. So then when I'm thinking about what is the sine of y, the cosine of x and the sine of y, opposite over hypotenuse, 48 over 50. The sine of a is 3/5, that's one of your acute angles, is the cosine of the other would also be 3/5. Sine of y is 5 over 8, which is also, which of the following is also true? Well, the cosine of 90 minus y would be the same thing. Okay, so there we have it. Remember, the sine of one angle is equal to the cosine of the other angle. The tangents are reciprocals, and in similar figures we reduce to the same trig ratios.